Hey, everybody. Today we're going to be looking at some business. Yeah, I'm not a programmer, but I sure love compiling things every once in a while just to see if I can make them faster by using different compiler flags. And, yeah, today we're going to do a thing. I got this thing that I looked at before, which is a fractal generator. It's in C++. It does stuff. You can see all the code. I'll have this all up on GitHub. I didn't make it. Other person made it. Right here. This is the person who made it. And I have 3 different versions of it here. I have generic optimizations, which I will show you. We have no whole program optimization. We have favor speed, just default options here. No whole program right there. We got code generation that's using AVX2. And that's pretty much about it there. And we have this other one that uses the Intel compiler. Uses whole program optimization. What else we got? We have special stuff here that does special things. It says it uses AVX2, but when you go to the code generation Intel section, it's actually optimizing for my processor, which is a Comet Lake. Coffee Lake's all they have. These are all the processors that are listed in here for people who care. You got all that. And we got the second thing here. It's also for Coffee Lake. They don't have Comet Lake. I don't know why. Maybe it's because they're the same. Yeah, we have all that there. Got no Spectre crap or anything like that. We have no security. It's fine. We got all this stuff. Yeah, we got stuff on that one. And then we have another one that I call just bad on purpose. And this one, no optimization, default everything here, no whole program, no enhanced instructions. And they're already compiled. I compiled these two, just go and build, and I made it go into different directories here. So we got generic, Intel optimized, and just bad. The Intel build, there's a thing that lets you do profile guided optimization. I looked at the documentation to make sure I'm using it properly. Pretty much am. So I ran it, and I'm not going to build it again because then I'm going to have to do that again. I'm not going to do that while it is recording. So let's start off with just generic. Start that up, and I have a task manager over here so you could see CPU business. So it starts up immediately doing 4,096 iterations, and we're getting 19, 20 frames per second. You can see the time taken yourself, and you can see how much of the CPU is being used. It's almost 100%, right? That's almost 100%. Okay, so let's close that. Let's look at the just bad. Oh man, we have 100% here. It's slower. 5 frames per second. That's horrible. This is bad. So let's close that. Then we have Intel optimized here. Let's run that guy. This one's the fastest. It's also using about the same amount of CPU as the generic optimization version, but it's just a tiny little bit faster. We could dig into that. Let's find out why. But yeah, it's interesting. This is interesting if you made it this far. Congratulations. Yeah, simple compiler flags can drastically change the way a program works. Say that this fractal program that I was messing around with was a benchmark that I was using on my website. Would you consider the generic version that I compiled to be a more representative look at the processor that I'm currently testing? Or would you consider the more optimized code path to be more representative of the hardware that it's running on? And obviously, what would you consider bad on purpose? I mean, if you could compile a benchmark, if it's all C++, if it's not handwritten assembly, what do you consider a more valid benchmark in the end? I consider this one. I consider the Intel compiler version the more representative look at the microarchitecture, because it's using everything that comes with the territory. I'm able to use vTune. I'm able to use the Intel compiler. I'm able to use all of these things that allow my program to run faster on the hardware that is in question. And if I have control over the source, why wouldn't I do that? If I'm buying, if I'm a company buying 10,000 fucking, Xeons for a server, am I going to be running this generic one of my C++ workload or whatever workload? Or am I going to run this one because time is money? I wouldn't run this one. No one would run this one. I don't know. Yeah, that one's just a joke at this point. I would run this one. And for a benchmark, I would want to see, well, what is it like if I'm using everything that comes with the territory, the whole ecosystem? If you have a benchmark and you're using an unoptimized binary, then you're just testing the compiler, an unoptimized compiler. It's not. Computers are complex. Time is money. And you need to give the whole picture and not just a quick chart, I think. And if you have the ability to recompile a benchmark, then, show both. Show both. Show how this runs on, this hardware, and show how this runs on this hardware, but then say that this is optimized for this system. Not as a bad thing, but as a good thing, because this is what you get if you buy this system. If you get this other system, maybe you don't get all those things. But maybe you do. Who knows? And again, okay, you're saying here 22, 23, 24 right there. And let's look at generic one more time. 29, 30, 28, 29, 30 right here. Can't get any more detailed than that because I don't know how. So let's launch the vTune profiler that won't possibly break my computer because Windows Insider. I don't know, weird things are going on with my computer right now, but it's fine. It's fine. So let's configure the analysis. Let's take a look at generic first. We're going to do microarchitecture exploration. So you're going to be able to see business. It's cool. It's on full finalization. So let's just run it. Take a second. That's fine, I'm sure. Because it's just looping. It's just doing the same thing over and over and over and over and over. Okay. So here's what we have for this. It's pretty much meaningless right now. I'll agree with you. That's pretty much meaningless right now. That's cool. Because we got nothing to compare it against, right? We don't know what that means. Let's see why just bad is just bad. Let's run that. I'm sure that's fine. This is a good video so far, isn't it, guys? I bet you're highly entertained. Look at that. Target utilization. It's great. It's perfect. It's beautiful. Oh, man. Okay. We'll get into more detail on that later. So let's look at Intel optimized and see why that's fast. Let's let that go. I'm sure that's fine. Sure, all this is fine. Okay, so let's put these in order by speed. Wait, can I drag these? Oh, you can't drag these. That sucks. Okay. So let's see if we could make heads or tails of any of this. We have, what's something that completely sticks out? Wait, can you compare these? I bet you can. Compare results. Ain't that something? So let's compare, what is that? 03 to 05. Compare. Yes. What does that mean? Oh, we don't have permissions. That's fine. Did I not? I swear I did. Why did it do that? Let's figure this out. No, things are happy now. I guess, oh yeah, it didn't close 05, so, okay. It's fine. So... So you have the slow one versus the fast one. So negatives are good. Negatives are bad. Slow versus fast. So you want less of some of these things. Yeah. So is there anything interesting here? No, I can't really get anything out of that. Okay, let's go to the... Let's just flip between them. Because remember, I don't know nothing about nothing. And I'm not saying I know the best, but I'm saying what I definitely can do is put source code in a thing and flip a couple boxes to make something faster. That is something I definitely can do. I don't know why it's not showing a thing here. Okay, we got some hotspots. Let's do this as hotspots. I'm not cutting any of this. You're going to be getting all of this live, as it were. I'm sure user mode is just fine. Like, I only run it for a dot, 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 and then I'm done. Huh. Maybe I should have let it run longer. If you see significant hotspots, there's not really any. It seems to be thinking it's doing as good as it could do. Okay, so let's look at one that's completely broken then. So what does it think is a hot spot here? It's probably because it's all scalar or something like that. Yeah, because it's all scalar. Okay. Oh, that's cool. Man, this is such a cool program. That's just part of the Intel ecosystem, isn't it? Poor utilization of logical CPU cores. Algorithm. Hotspots. Yeah, that's what I thought I just did. Well, let's try this one. Man, this stuff's so cool. You could just do this. Let's give it 10 seconds. Okay. It tells me what the thing is. Look at that. Memory stalls, instruction starvation, branch misprediction, or long latency instructions. So you could run microarchitecture exploration analysis to identify the cause. Look at that. That is just cool. So yeah, I could do that. What is all that? Cool. Yeah, sure. Let's give that 10 seconds too. That's good. Sure, that's fine. Like, this is the slow one, so it should be pretty easy to find out. Okay, yeah, it's remaining empty. Yeah, I mean, we already kind of know why it's slow. It's just not using any AVX or anything. It's all scalar. But I want to see the thing that shows the hot spots. I forget how to do that offhand. I mean, it kind of is. I mean, you could sort it. You can see how it's retiring stuff. I'm retired. Okay. What happens if I do that same thing for the generic? Because that one wasn't bad. Sorry, I'm going to take a vape here. Okay. Okay, that's fine with me. Give that another 10 seconds. Probably the more time you give it, the better, really. But these things take up space. Yeah, we need to sort this by CPU time. The other way, please. Oh, there you go. Yeah, it was doing it right. Worker thread create. If we drill down more into that, oh no, call stack. $23.8. Okay, we're going to close you. Now we're going to do the fast one. Okay. That's interesting, I guess. It's showing different things here. Oh, just some thoughts, just some observations. See ya.